You can sync up those tool libraries and what tools are in what position of the machine and what options are engaged so that as people start programming, they already know they're getting the right tools with the right functions. And then we'll also take a quick look at some setup sheets. Now in Fusion 360, this is a slide I've shown you previously. You have 2-axis cutting. We also have 2-axis, 2.5-axis, and 3-axis milling. We have 5-axis milling, which is available to you for free. And you also have access to the advanced machining extension, which will give you some advanced solutions for things like steep and shallow or some of the more refined capabilities that come with Power Mill or Feature Cam, which are other tools that Autodesk offers for CAM, that some of those are available to you through the Autodesk education community. We have turning and mill turning. Tonight we'll be focusing on milling, but we also have additive manufacturing, which we've taken a quick peek at previously. So tonight, what we're going to be doing is taking apart and walking through the process of machining it, setting up the programming. It'll take actually 4 setups, although the last 2 setups are the same setup with the part flipped over. We'll be walking through this. Now, what I would like to do is ask you, while I'm going through the initial stages, to please just watch, and we'll give you a couple of minutes or a handful of minutes with each stage, because there's a lot of them, to do the hands-on yourself, and there will be the information will be on the screen with the pertinent numbers, the options, and after we get used to the interface, you'll find that you're able to walk through the operations very quickly. And I'll also try to include as much information in the background on why the one toolpath might be a preference over another, although if you have expertise in CAM, you'll probably be able to pick out the appropriate toolpaths for your specific part. And that's another area where simulation can be very, very useful. So to begin with, one of the things we're going to be doing is opening up a standard part. So let me just do this very quickly in Fusion 360. Let me back up here. And where we're going to be going is all the way to the bottom of our data panel. So if you don't have your data panel open, you'll need to open it when the time comes. We'll be going all the way down to the bottom of samples, and I'll go back to the slide where it has this path in a moment. But for those of you who are more visual learners, I'm going to be going to workshops and events, then going to education, and just double clicking on the folder. And then right there is CAM. And then at the top, CAM bracket workshop, and I'm going to select the very first file, which is bracket cam-starter file. In this case, they left the V2 on there as well, and that will bring up the file. So let me give you just a minute with that to go ahead and get that file. Again, if you scroll all the way down to the bottom in your data panel, if you click the home icon, that will take you to your list of projects. Scroll all the way to the bottom to the samples area. At the very bottom of that list is workshops and events. Double click on that, then double click on education, double click on CAM, and then double click on the CAM bracket workshop, which should be at the top of the data panel in that last folder. And then you'll see a few different options. You'll also note that in that folder are some stage files. So for example, if we get through stage 1 and maybe you missed a step or a toolpath didn't work out for you, we'll be able to go ahead and start the operation 2 or operation 3 and 4 file as well to be able to come back to it. I'll also take kind of a PDF that's for a queue. In fact, I intended to do this first. Let me see if I can drop this into the chat for those of you who are online. Doesn't appear so. So what I will do is I will send this to Francis and he can send it out if you request it, or my email will be at the end of this. Please feel free to reach out to me if you want to try this again on your own pace. Okay, so with that said, what we're going to be doing is we're going to be doing 4 operations, but 3 unique operations. The first one that we're going to be doing is a series of operations that will take multiple steps. We're going to be doing some 3D adaptive toolpath. What that is a clearing operation. That will remove a lot of the material off of the component. Then we're going to be doing an outside profile. We're going to be clearing off the top level of the main part. Then we're going to be boring out some holes for drilling and boring holes. And then we'll be rounding out the top of those ears and then doing some chamfering of the edges to clear things out and make it easier to put bolts into the holes. All right. So just to give you a little preview of what our exercise is going to be, this will go through our first operation initially. So this is going to be the adaptive clearing that will be done. As it rounds out the tops of the ears. Your specific program might look slightly different than this as far as its actual tool path, as the algorithms sometimes get updated. Then we'll be able to profile the outside. Then we'll be clearing off that level, doing a drilling operation, then boring for the counter bores. Then using a flow tool path to clear off the tops of the ears, as well as build the fillets that are adjacent to them. And this all probably or possibly looks very complex, but you'll discover that the way Fusion 360 works, this will be fairly simple, even though there are a lot of steps. And then after it's done with that, we'll begin processing the second side as we leave a good amount of material down at the bottom in order to hold that workpiece while it gets cleared out. Add some details, and then we're on to a boring operation and then adding the final chamfers. So that will be what we're doing tonight in the remaining hour and 15 minutes or so. And so to begin with, I'm going to create my first setup. So as I mentioned, what I'm going to do is I'm going to go through the operation and then I'll bring that slide back so that you have the detailed information. So please, just for the next couple of minutes or hopefully faster, just please watch. So one of the things that's important to know about doing an initial setup, what the setup is kind of declaring what the material you're going to start working with is, how it's going to be oriented on the machine, and then being able to declare things like giving it a name for the G code so that when you're creating unique programs for the various setups, it's easy for you to tell which one is which. An important element of this is if you're going to be working with data you did or even didn't create in Fusion 360, the setup operation allows you to go in and change the orientation regardless of how the model was oriented. So for example, the initial orientation of our axis for the programming is the same as our model, but maybe that's not what we want. If I want to change the orientation of an axis, I can click on the shaft of the arrow and then pick on a face it's normal to. So in this case, it's taken X and moved it off to the left. I'm going to relocate this cube by picking in the middle of the triad. I want to put it down in this lower left corner. And then I'm going to flip X by picking on the tip of the arrow. You can flip any of these axes by changing the tip. So this is the orientation that I want. Z should be up. X will, if you were looking at the machine, essentially our block would be sitting in it like this. Positive X would be going to the right, and positive Y would be going away from you on the machine. So that's the first thing we're going to consider is what our setup is. In fact, we'll take a look at these tool panel on the right. The next tab is stock. So right now it's generated a box relative to the size of the part itself. That's interesting and all, but more often than not, what you're going to want to use is a fixed size piece of material, either a cylinder for turning or a tube for a hollow component, or from an existing solid if you're going to be machining a casting. So here we can say that we want a fixed size box. I'm going to put in an overall X value of 2.25, an overall Y depth. Once again, I'll be sharing these values with you of 2.25 and an overall height of 1.75. Now, right now that is centered on my part, but we really don't want that. What we want to do is be able to control how much material is below the part in order to grasp that in our fixture or our vise. So I'm going to say, based on the bottom, that I want to maintain material. I want an offset of 2/10 of an inch. So you'll see the whole box shifted down, and any rounding is based on 1/4 of an inch. Okay. So we've got our material. We know how much is going to be below it for work holding. Then what we want to do is establish a program name. So we can put in 10001, maybe give it a name that means something to us. So first operation or first op. And then because we're going to be working with multiple coordinate systems, we want to track this as our first coordinate system. We'll simply click OK. And now Fusion 360, as far as Fusion 360 is concerned, we have a box that's 2¼ inches from side to side and front to back, and 1¾ inches from the or top to bottom, and it's offset 2/10 of an inch below what will someday be our part. You know, Michelangelo said something to the extent of, you know, the angel was already in the marble. My job was to set him free. That's essentially what we're doing here. This yellow box represents our marble, and we'll be setting our part free. So here's your setup. Here's a reminder of what those values were. So again, set your coordinate system in the lower left corner with X going off to the right as it appears. By the way, if you have a slightly different result on this, you might be able to work with it, but I do recommend trying to get that to work as set up. And if you can let me know and a few people have this ready, I imagine we might not be able to have everyone keep up, but hopefully we'll keep as many as possible.
Yeah, we have a few people that are ready, so you can continue.
Okay. All right, great. Thank you. All right, the next thing we're going to do is what's called an adaptive roughing operation. So let's take a quick look at our toolbar. The setup is the first stage. In our case, we're already done with setup. Then for milling, there are a series of 2D and 3D operations. The primary difference between 2D and 3D is the 3D operations will detect the Z values and try and work at multiple levels, program at multiple levels at one time. Certain machines will be able to work with these. You know, for 3-axis machines, 5-axis machines will be able to work with these. If you have strictly an old CNC mill, you might have to stick with 2D operations. Then it goes with drilling operations. The multi-axis operations will need to be enabled along with the machine extension. And down the line here is where we'll be able to control our post-processing, our generating toolpaths, and simulation. Then further down, we'll be able to manage our library. So the first operation we're going to do is called a 3D adaptive roughing. It's a roughing operation. So I'm going to select adaptive clearing either directly from the 3D panel or the first icon on the drop-down list. All right, so let's take a look at this toolbar. For the most part with milling, all of the tools and tool paths that we create will have a slight variation on this. So the first tab is your tool tab. This is where we select a tool. This is where we put in our speeds and feeds information. Speeds and feeds information are the information the machine counts on to know how quickly it can move the tool, how quickly it can transition the tool from location, and how fast the tool needs to be spinning in order to remove material. If you set up your library correctly, or as I said, if the school sets up a library, this information can be put in based on the machine, based on the tool, and based on the material, which will make it much easier for people to program. Most of the tools we'll be using today are already built into this file. That's another great thing about using this. So take note of the speeds and feeds information as we go. The next tab will be geometry. In many cases, we'll be selecting specific geometry to set up our toolpath for, to remove. Height controls where the tool will be. So where you might have a retract height, that's where it's going to lift the tool up to be able to clear the part. A clearance height will be well above that. A top height is where it's going to expect to be able to engage material. A bottom height is where it's going to stop removing material before it gets down into the fixture or it gets below the point where the tool can function. All right. Then there'll be a passes tab. The passes tab is where we'll make a lot of modifications, although they're fairly simple. What the passes tab does is controls what happens or what's going on when you start removing material. Are we going to be taking, you know, is it going to take multiple steps to go down? That's your maximum roughing step down value. Your fine step down, you can control what happens when the tool is engaged with the material. The linking tab is what happens between cuts. So how quickly the tool lifts up. If it lifts straight up and then transitions, or it starts to arc as it makes a transition to save just those few milliseconds. This is where all of this is controlled. The exercise we'll be doing tonight is going to be relatively straightforward, but let's begin by selecting a tool. So selecting a tool, you'll notice on the left, this is where you can access libraries. You can also down in the lower left, download libraries from various vendors, people that make these tools. Again, this is also where you can connect to a school library. In this case, the part already has all of the tools that we need built in, and we just need to go step by step. So the first one I'm going to pick is number 1. All right, so I'll be able to select this. You'll notice down here at the bottom, there's different cutting data for a finish cut versus a roughing cut. And we'll be using a selection of these throughout the night, though most of the time we'll just pick one or the other. So in this case, I'm going to select aluminum roughing for tool 1 and pick select. You'll see it updates the spindle speed. The spindle speed is the part of the machine that holds the tool and spins it. You'll notice that if you hover over any of these elements, it will give you a tool tip on what's going on. The next thing we need to do is we do not need to select the geometry because adaptive clearing looks at the whole part based on the Z direction of the tool and just figures out what it can cut from that position. We do, however, want to establish a change to the height. So for example, the bottom right now is set flush to the bottom of our part. What we actually want is the tool to dip down slightly below the part so that when it makes a cut around the perimeter, the smooth geometry that it cuts is below where our final part will be. So we'll need to make a modification here. We'll say based on the model bottom, I want to create an offset of minus 60 thousandths, 0.06. And I'm coming up with that because that is twice of what the corner radius is for the part. Okay. I also need to make some changes on the passes tab, and please, once again, just kind of watch what we're doing for now. You might have to turn on flat area detection. You'll want to set your fine step down. You can do that in a couple of different ways. You can type in 0.05, which is close enough. Otherwise, be aware that there are expressions that are involved as well. So for example, I can click on the expression, see that it's calculating based on the diameter of the tool and calculating based on the maximum step down. So I could calculate to be 3/1000 of the maximum step down. That's interesting. I'll just set that to 50/1000 here for the fine step down and click OK. What it will do is calculate out the tool path. As you'll see, it's calculating this out to do things in multiple stages. And it gives us a preview of what will be left of our material at the end of this process. So let's go ahead and have you do that first tool path. Again, it's a 3D adaptive tool path. You'll pick tool number 1, which is a 5/8 bullnose end mill. Go ahead and use the aluminum roughing preset. Then on the heights tab, that's how all these sub bullets are organized, is by tab and then what the values are. In some cases, such as for heights, you can just simply put in -0.06 for that bottom height below the model bottom. Oh, I missed a step. Let me correct this. I missed this bottom line here. So let me go back to edit a tool path. This is a good reason to show this. All I need to do is double click on it in the browser. I'll return back to my passes tab. What I need to do is make sure that stock to leave is on. What stock to leave does is it leaves extra material, either axially or radially, around where the tool is cutting, or both. And instead of 20/1000, I just want 15/1000 for both axial and radial. And that will update that tool path. It'll just take a second. In fact, we can just switch back to this so you've got your values back. And then again, please let me know if we have some folks who are done or if all of you are done.
Continue.
Okay. All right, the next thing we're going to do is cut out what the footprint of our part is. Okay. And again, we want to make sure that our tool is dropping down below this bottom edge. So what we'll do next is start a 2D contour. This is under the 2D tools. A 2D contour will leave our tool to be the same. So we still want to use our 5/8 bullnose. On the geometry tab, this one is a little tricky. We want to make sure that we pick the outside edge, but we're also, because we have notches on the bottom, we also need to grab the edges that kind of fill in this notch. And if I look at it directly at the bottom, we can see it does form a perimeter, even though their preview is at 2 different levels. The only other change I'll need to make is at the bottom. Instead of using the contours that were selected, which is a default in the case of the 2D contour tool, I want to change this by clicking on where it says selected contours and say model bottom, and then set this value to -0.04. That will lower the tool down below that edge 40/1000 of an inch. When I click OK, it will generate the toolpath. You'll see it just curves in and then curves back out. So let's go ahead and have you set that. One of the things that takes time with setting up tool paths, and that I'm still fairly pretty much a novice on, is really kind of choosing the order of these operations. If you have the opportunity, if you're in an engineering field, um, take as many manufacturing classes as you can. It really helps when you're creating products, creating uh, components, to understand how they're going to be processed, to make sure that your design integrity is there if you're not using generative design to help you with all of this.
Hello. Why is the tool corner radius is 0.01 inch here? I thought it's
Uh,
0.03.
yeah, it's okay. You can just ignore that for now. I should have pointed that out. Apologies. Just focus on the minus 0.04. If you don't select those short edges on either side, you'll see your tool path kind of dip in because it's trying to cut into those notches, or follow the radius that's at the bottom.
Yeah, I think the people that are attending in person, I think most of them are up to there already.
Oh, okay, very good. All right, the next thing, I just want to point one thing out. You might notice that, well, when it's, let me see. Yeah, it's okay. I was going to point out on some of the imagery, you can see that when we're running the toolpath, you'll be able to see that there are edges that are not quite coincident. And what that is where we have additional material. So for example, we left our roughing 15 thousandths of an inch all the way around everything and on top of everything. So now we need to start clearing some of that off. So for this, we're going to run a horizontal toolpath. This is under the 3D tools. We'll continue to use the same tool, the 5/8 bullnose end mill. Okay. Now the only change we're going to make here is to run, change our heights. And in this case, we're going to change the height, the top height, to be based, I'm going to change it to be based on the model top minus 1/1000th of an inch. And the reason for this is the adaptive toolpaths, the 3D toolpaths, will look for opportunities to start removing material. If we don't start this a little below the top of the actual part, it will start trying to remove material that it's not really ideally suited for. We want to focus on removing the material on this level. So I'm just changing the model top down 1/1000th of an inch, calculating the tool path, and having it set itself up. Okay, that's our horizontal tool path. That will also cut out, remove the excess material around the inside, front, and back of our ears. So the footprint of our ears will essentially be cut to exactly what they need to be. Looking good?
Oh yeah, sorry, we were muted. Yes, I think we're here. We're good here.
Okay. All right. All right. The next operation I'm going to do is do some drilling. So this is going to look a little bit different because as we move from different classes of operation, for example, milling versus drilling, you start to get little different tab setup. Pardon me for just a second. So what I want to do is create a drilling operation. So I'm going to come over here to the drilling panel. And I need to change my tool. Now, in this case, because I've launched a drilling tool, you notice I don't have as many tools. The other tools are all classified in the library as milling tools. This one is a hole making tool. So it's important to know that you can classify these tools to also make it easier for you to find tools based on the type of operation. But Fusion 360 also throws in this little bit of extra intelligence to know that hole tool or tool number 2 is this 1495 drill. It's a number 25 drill, and that's a clearance hole for, I believe it's a number 6 fastener. You'll notice also down below there are a lot of presets based on the different material. So you can see just by the plunge feed rate, the surface speed, the spindle speed, what the difference is based on the softer materials like aluminum and brass, getting all the way down to the harder materials like stainless steel and titanium and high carbon steel. All right, in this case, I'm going to leave aluminum drilling in place. All right, now in the geometry tab, I'm going to pick one of these holes, and what I want to do is make sure I just pick the drilled hole down here. I'll select that, and then I'm going to take advantage of some automation. For example, in the dialog, I'm going to select to choose holes of the same diameter, and you'll see that my hole operation might not get me what I really want yet. So I'm going to continue to make changes. So for example, I tell it that I want to go ahead and auto merge hole segments. So since this hole starts at the bottom of a counter bore, that counter bore won't be there yet. So I don't want the tool moving rapidly down to the top of where that hole will start eventually, because it's not there yet. So I want to auto merge the hole segments to make sure that it slows down before it hits where that counter bore will be, because there's still material there. So I'm going to select that option, and you'll see it brings the height of the perceived hole up. Then, as long as I'm kind of looking at the side here, I want to switch to the heights tab, because we want to make sure that that drill goes all the way through. So there's a checkbox here for drill tip through bottom. So you see now it brings the flat of the drill all the way to the bottom face instead of just the tip. And then we can add some additional depth. So I'm going to add 50 thousandths to that to make sure that the drill goes cleanly through what will eventually be the bottom of that part. After I say OK, it generates the toolpath. You can see that our toolpath generates the high-speed transition is in yellow, where it's engaged and cutting is shown in green. All right. So that is our next toolpath.
So there was one question on whether the drill tools can be migrated over to the milling section or vice versa, because since a lot of the tools would be interchangeable.
In some cases, yes. So for example, you might do a boring operation with a drill, and you also might do a boring operation, as we'll be doing in just a moment, with an end mill. So it's really just how you want to classify it in the library. But in a little while here, we'll be doing a drilling operation with a milling tool. It'll be an angled milling tool that we'll use to create a chamfer. So the short answer would be yes, you can go back and forth depending on whatever, as long as you've got the tool, you can misuse it in whatever way you want. Or you can use it however you like.
Follow-up question was, can we just end up using the mill the entire time instead of having to switch to the drill?
To do that, you'd have to do a boring operation, and the mill would have to be small enough to make the hole. If you go at it that way, now in some cases you're just limited on what cutting tools you have. So you could make those holes using a small enough mill by doing a boring operation, having it work its way into the material, very much like we'll be doing here in just a couple of minutes. So the answer is kind of yes, but you always want to try and get the best tool for the job.
Questions online?
I'm sorry?
I was asking the online people if they have any questions.
Yes. There was a question that I'd missed about do you select any hole? In this case, because you can use that option to auto select the other holes, as long as it's one of the smaller diameter, the lower drilled holes down at the bottom and not the counter bore, the answer would be yes.
In-person people are ready to go.
Okay, great. The next thing I want to do then is create these counter bores. And the issue with using a drilling operation to create the counter bores is, of course, they have flat bottoms. So we'll need to use a different operation. And I've alluded to it a couple of times. We want to use a bore operation. And a bore will take a mill and wind it down in a spiral. So for this, I need a different tool because right now, the last tool we used was a 5/8 mill. I believe the diameter of these things is less than a quarter, or it's 0.281. Just by hovering over it, I can see what that diameter is. So I'm going to select tool number 3, which is a 1/4 inch helical end mill. Okay. And we can use either operation's fine. We'll just select that tool. Now this one is going to take some different settings. So after I select geometry, much like the drill, I'm going to pick one of the faces of a counterbore cylinder. Then, using the same basic option I used with drilling, I'm going to ask it to find the other holes of the same center. So I'm going to switch same diameter on. Then I want to go to my passes tab. And here's where we can establish what the angle is. What is the spiral angle that's going to be coming in, as the tooltip shows? In this case, with aluminum, we can be a little more aggressive. So we can say we're going to set that to 5, so it will wind down at a steeper angle. Now, here's another interesting element. A lot of these operations have compensation types. What that is it will ask, how do you want to deal with the fact that not all tools are perfect? Do you want to go in and put in the information on what the actual size is? Or in this case, you can say where you can say in the machine, you might from time to time measure your tools and go, okay, this 1/2 inch end mill, this point in time is now 0.493 diameter. Put that in your machine. It will modify the G code to compensate for that. So we're going to switch that to where operation. And then the final option I'm going to select is under linking, I'm going to click on lead to center. So what that's going to do is, instead of just coming out in the perimeter, winding down, and then kind of lifting up wherever it is and possibly scoring the side a little bit, I'm going to have it pull back into the center and then lift out. So I'll check lead to center as the option and click OK. And that will give us those 4 little spiraled boring tool paths.
All right, missed where you started bore command.
The bore command is under the 2D panel.
Oh, okay.
I believe it's about 2/3 of the way down, or slightly over halfway down.
Yeah, we're good.
Okay, we'll give it just another few seconds. Yeah, and as you get more comfortable, these steps will actually get a little simpler. There are a couple that get a little elaborate, but hopefully we'll just continue to kind of accelerate a little bit. By the way, I think we're about half done with all of it. But as you can see, even though there's a broad variety of approaches and what the toolpath does, the consistency in the dialogue makes it a lot easier to kind of find things. Even though, as Fusion 360 goes, the CAM dialogues have more variety than most tools. All right, so now what we've got in our part.
I have a question.
Sorry?
So where you enter the where? compensation type, but how do you know where do you enter that information?
That's actually done on the machine. If you select where, what it's going to do is ask the machine what its diameter is for that tool.
On the machine? Where?
On the machine in your tool library on various machines, certain machines won't have this. So that's why you have different compensation types.
Oh,
So
you
for
mean the
example, if you have,
actual CNC
on the
machine? I see.
actual, on the actual, pardon me, yes, on the CNC machine, I should have been more clear. But the reason there's differences, I'll just kind of finish that thought. So is on one of the more advanced CNC machines, you can update its tool library to let it know what the realities of its tools are at that time and where compensation can make up for that. However, in control or in computer, you might have to put that in manually if you have something like a CNC bridge port that will literally take anything you stick in the chuck and just move it without even knowing. So you have to be semi-manual there.
So
All right.
how does know? So this information is passed through the post processor?
Yes. Yep. That information is passed through the post processor to the CNC machine to take a look at the values in a case where you're going to have a machine where compensation is valuable. The G code, I think it was G42, prompts the machine to take a look at what its values are.
Mm-hmm.
Okay. So now where we are on our part, if we take a look at this, we now have our counterboard holes made. We have this surface nice and flat. We have our profile proper. We have the profile of our ears looking down on the part proper. We're getting down to the details now. And one thing we obviously need to do is to smooth out the tops of those ears. So that's the next thing I'm going to do is I'm going to, under the 3D pull down, I'm going to use a flow tool path. And I'm going to pick the semi-cylindrical faces on the top of the ears. Now the arrows, over time, something that you'll pick up on, or you might have noticed, and I haven't really addressed yet, is you'll see little arrows appear here and there on the tool. So we can pick and choose either on the geometry, like we did with our axis, or using our passes tab, say that we want our tool paths along V. Here, let me flip this one back since I messed that up. Pardon me, let me redo that. You should either pick them on the icons or pick them in the dialog. Don't cross the streams on that, or else you make things kind of a mess. I'm going to say along the V direction. So it's either U or V. It goes way back to the old surface modeling days. So that's the direction that we want our tool path to take. And this particular solution is just going to go back and forth along the tool path. And right now, one step over isn't going to get me much. So I want to change this value to 20. So on each one of these faces, I'm going to have it step over. It'll be divide the width of that face by 20 and just go back and forth over the part, just like that. And you'll see the curvature that's created because, oops, I forgot to change my my tool. Okay, so see how that looks, and then compare it to when I put the correct tool in, pardon me. I need to change my tool. I'm going to change it to number 4, which is a ball end mill. A ball end mill has a semi-spherical tip, a completely rounded tip. And once it generates the tool path using that, you'll see instead of it going down and having a sharp corner drop off, it's a smoother arc around either side. So that's another thing that's great about these previews is if you see a toolpath result that you really don't think is quite right, you might want to check a variable, or in this case, look for something fairly obvious, which is picking the wrong tool.
Hi, Tom. No questions here.
Okay, very good. So we're going to continue along that same path here with the next operation. You'll notice if we look closely, the vertical faces here are nice and round with our tool path, but these edges are sharp and actually kind of jagged now that we run that flow tool. So let's use flow again, keeping the same tool. And in this case, we're going to select each one of the fillets. Now, if you want, you can zoom in and kind of pick it from the side, or of course, you can pick it and orbit each time. You'll also notice that the tool right now is going to be going across the fillet like this. That's a lot of extra motion. So I'm going to go to the passes tab, switch this to along V. So it's going to be following that long curvature. And let's do a smaller number of step overs, but more than one. Let's go with 5. That should smooth it out very well. You want to make sure you pick all 4 of those faces, and you'll see what that tool path ends up looking like, as initially it makes contact with the material with the side of the ball end mill and works its way up closer to the tip. So that is our top round fillets.
We are good to go, sir.
All right, wonderful. All right, now this next one is going to be a little more complex. Even though the tool itself or the operation is relatively simple, there's going to be a lot of options, because what we're going to be doing, kind of to the earlier question, is taking a tool and using it in kind of a novel fashion. So the first thing what we're going to be doing is applying a chamfer around these top edges. But of course, we can't get too close to the ears, otherwise the side of the tool will strike it. Okay, so we're going to need to use a lot of control over the tool itself. The other thing is we're going to be using a tool with a V-shaped tip, or a conical tip is honestly what it is, to be able to cut this chamfer. So we can't just have the tip of it right on that edge, or else it'll mess up the tool and mess up the edge. So we're going to have to offset things and drop things down to add a feature that really isn't even in the design file. So there's no chamfer on our CAD file, but a good machinist is going to want to break those edges to keep a good quality part. So what we're going to do is another 2D contour tool. I'm going to select the 2D contour tool, and then I'm going to come in and choose tool number 5, which is a 1/2 inch 45-degree helical chamfer tool. All right. Now, what I'm going to do next is, using the geometry tab, I'm going to select this edge and this edge. All right. I'm going to select those 2 edges. Now, I need to be able to control. You'll see that it's running that tool path right up to where this fillet is, which would squarely put our tool a good 100 thousandths or more into that ear, which is not a desirable outcome. So what I want to do is tell it to do the tangential extension. What tangential extension is usually used for is if you have your material and you want to bring your tool in and level it off before it gets to the edge that it's going to be cutting, you would use tangential extension to curve in and go flat before it makes its cut. However, you can also use a negative value to where it comes in after the edge or away from the point. And with a contour, what you're looking at is the beginning and the end of the tool path less than the edge of the tool path. So we're going to put in a minus 70 thousandths tangential extension. So we're actually going to hold the tool back 70 thousandths from its start point. That's the first variable we'll be setting. The next one will be on passes, where we're going to tell it that we want to turn on the chamfer. Yours might be off when it comes time. Okay, we're going to establish what our chamfer width is. So how wide is that chamfer from the Z? So it's going to be 15 thousandths of an inch. All right, that's all well and good. Then again, like I said, we want to make sure the tip of our tool is out and away from the part. So we're going to set that out 190 thousandths, so 0.19 inches out away from the edge of the part. All right, the last thing we're going to do is focus on the linking, because we also need to control how this tool is going to come into this part so it doesn't come from the wrong direction or sweep in from the side. All right, so we want to make sure that we have a horizontal lead-in radius of 0. So we don't want it to curve in. We want it to come in straight, so the conical end creates a nice looking chamfer on our part. So we're going to set that lead-in radius to 0. We're going to have it come in 90 degrees from the path. And then we're going to go ahead and set the lead-in distance to 0.1 inches or 100 thousandths of an inch. So it's going to come down 100 thousandths of an inch out and then come into the part. So our conical face will be at the right level and it'll be very clean. And we want to make sure that perpendicular is on. So it comes in perpendicular to that path. Okay. So it's going to come in, going to come down, slide straight in, go around, and come out the other side. And you can see in the preview, something I haven't been pointing out as much as I should is the preview is going to show us how that comes in and comes out. All right, so let's go ahead and have you do that. This is actually one of the more complex ones, if not the most complex one we'll do. So take your time and make sure that you check each one of those tabs. So you'll be changing the tool and the tool tab, setting the two edges with the geometry tab, and setting that tangential extension on geometry tab, then passes tab and linking tab. So you're using everything basically but heights.
I have a question on the tool set, tool library in
Yes.
that we used, because I saw all these parameters have already been set for us. Is it all coming in standard, or are these set up specifically for this workshop?
The library that we're automatically finding is set up specifically for this workshop, and it's already embedded in the model itself. That's another thing that's kind of unique about Fusion is once you attach a library, or even if you use one of your standard libraries, as you use a tool, it kind of attaches itself to the design file itself. So you're able to access it more quickly. What you'll need to do to set up a library is you'll need to work with the shop. If you work in the shop, you can help set that library up, or work with the shop to find out what the correct speeds and feeds are. It would be fantastic if the shop or probably multiple shops on campus, if they were using Fusion 360, if they could get involved in or create a library for the students themselves.
Yeah, so for this particular tool, the spindle speed 12,000 RPM. I don't think any of our machines can reach that.
Yeah, yeah, exactly. So you would have to take that tool and set it to what the realities of your machine are. And that's, again, if you're one of the machinists, you would have a feel for what speeds and feeds work best for the material for that particular machine and that tool type. And that's what you want to build into your library, so that knowledge is already there. It's great for people to take a machine course and understand what all of that means, and to develop a feel for how to make modifications to that based on what the appearance of a cut is. But it's always best if you can shortcut the process or accelerate the process by building that intelligence into the tool library itself. And I've mentioned that Fusion 360 can share the libraries. You can, of course, send someone a library, but those libraries can also be posted on the cloud itself. So dropped into or associated with a project so that anyone in that project can connect to it. The other advantage of using cloud-based libraries is that if the speeds and feeds need to be adjusted, maybe it turns out someone did some experimentation, and with aluminum, different spindle speed seems to work a little better with a particular tool. You can update that, and next time someone goes to use that tool, it will have the latest and best information. All right, how are we looking?
Everyone seems to be following along, sir. No questions.
All right, great. We're down to our last couple steps in this first operation or set of operations. The next thing we're going to be doing is using a drilling operation to put a chamfer. Actually, the next two things we're going to be doing, but we'll be using different size. So we're going to go to drill. And in this case, because the last tool we used was our 1/2 inch 45-degree chamfer, we can just leave that alone. We already have it. And then for geometry, we're going to go ahead and just pick one of the counterbore holes. And again, use that select same diameter option. And you'll see that it's going to give us that information. Now what we need to do is, once again, we're creating a feature that isn't in the CAD file. This is what machinists do a lot of the time, is you'll leave all these nice sharp edges on your design, but those are prone to nicks or they create handling issues. So they'll go in and run a chamfer or just kiss an edge, just break the edge. So in our heights, we want to make a change. So the top height for our needs to be set at hole top. If it's not already, you'll need to change that from that pull down library. And this is what gets pretty powerful. My bottom height, I'm going to set that to 2 chamfer width. So I'm going to have it set the bottom of it until the width of the chamfer gets to a certain value. And then I'll set that value to be 10,000ths of an inch, 0.01. Okay, so essentially it's going to press this mill down into the top edge of the hole until it's going to create a 10,000ths chamfer. Okay, and I should have let you see that a little better. And you'll see with the preview, it just creates that just a little bit of material removal. So let me give you those values. This particular toolpath is a great example, along with that previous chamfer, of how you can use the programming to add details to the component without having to put all of that into the CAD file.
Very good, sir.
All right, excellent. All right, we're going to essentially do the same operation, but we're going to be using a different tool. So once again, I'm going to go to drilling under the drill in the drill panel. I'm going to change the tool to the number 6. Now you'll notice here that because I'm in a drilling operation, when I go to change the tool, remember the number 5 tool was already the default when I started the last drilling operation. I'm going to have to switch over to milling tools because, again, we're going to be using that 45-degree mill, and I'll use tool number 6, which is a 1/4 inch 45 helical chamfer mill. I'll select that. It puts in the information here. For the geometry, I just want to pick one of the smaller, the drilled holes, and once again, use select same diameter. Then we're going to do essentially the exact same thing that we did last time. We're going to go back to heights, make sure the bottom height is set to 2 chamfer width, and even use that same value. In fact, in Fusion 360, I think I might have pointed it out in a previous workshop, but anytime you've used a value, if you move over to the right, you'll see the 3 dots. You can click on that and pick a previously used value. So in that case, I'll just pick my 0.01 that way. It drops this tool in, and we're off and running.
One moment, sir. There's a question.
I'm sorry?
I said 1 moment, sir. There's a question being asked.
Okay, yeah, I see that there's a question in the chat. The contour tool isn't selected automatically. You always have to select what tool you want. There isn't a provision in Fusion 360 to automatically select tools based on the geometry you're using. Well, let me half walk that back. In the advanced machining extension, it can look for features such as drilling operations, and based on the size of the hole, because mentioned before, you can put in clearance holes. So a clearance hole for a certain size bolt is going to be a certain number drill. It can automatically select things like that. Drills are the easiest thing to do because they come in specific sizes for specific purposes. I'm not aware of the ability to do that with mills and things like that. Was the question in the room, or was that the question that you were referring to?
That was the same question, sir.
Okay, great. All right, well, congratulations. You've actually just done that whole first operation, and that was by far the most challenging thing I planned to do. And so now what we want to do, and this is something I really like about Fusion 360, and it's something that normally when I'm doing something on my own, I'll run simulations frequently. In fact, sometimes I'll even do it after each toolpath. What a simulation allows you to do is take the little previews that we've been getting and be able to run them as operations. So to do a simulation, you can select an individual toolpath, or what I like to do in a situation like we have is pick the setup, then either through the right-click menu or from the actions panel in the toolbar up here, I'll pick simulate. Now there are some options in the tools. So you can choose whether or not to show the holder or the tool. You can choose whether or not to make the tool transparent. Let me zoom out a little bit so you can see the changes. Okay. You can show links between toolpaths, leads. So links are yellow paths between where it goes over or down, leads up and down, show cutting operations, show points. Your mode might not be set to tail. It might be all toolpath. That's okay, but it can get very messy by showing all those toolpaths, but it's all down to what you need. I like to show the tail operation. You can choose whether or not to include stock in this. I like to show the stock, and you can choose various colorization options. You can also show transparency of the stock. I kind of like that reveal effect by leaving the stock solid. And then what you can do is you can just press play and watch a simulation of what happens when the machine starts cutting your material. You can also click various points along the time bar down here, or even drag along the time bar to see different operations. You can also skip to next move or skip to next whole operation. So if I click back and start play again, you can also use this bar at the very bottom to drag your speed. So if I drag a little to the right, the speed will accelerate. And you simply do this to your comfort level. Another useful element of this bar is as you're going through, you can see what the operations are. If there are any crashes anticipated, they will show up as red ticks in that bar. You can also click on the Info tab to see the XY position, the feed rate, the movement, what the operation is, what tool it's using, and you can go to statistics and see what the overall machining time is based on the values that you have. But as you can see, our part is being cut, and it gives an excellent preview of the fact that the tops of those ears will not be perfectly smooth. They will be very close, but the type of tool path, and that allows you to visualize what your finished part will look like, and maybe go back and add additional steps to those flow tool paths.
Hello,
So if
why
I
don't
zoom
I
in,
get this pop-up dialog box? I only can see the graphics. I don't see that simulate with machine box. How do I
Has it
show
been
that?
minimized? Has it been minimized like this at some point?
I don't
What you
really
might
see
want,
it.
what you can also do, let me exit the simulation. You can press escape key to exit the simulation. If you go to back to the design tab.
Go to simulation.
Oh, here, I was
Go to
just going to show
design.
you a way to, where is it? Oh, if you go to your view menu in Fusion, which might be a little tricky, you can reset default layout, which if for some reason you've lost a dialog box or ever lose your browser, you can do that. This is showing control or option command R. So control alt R might do it in Windows. If someone can take a look at that, that will reset your interface. If you genuinely don't have that dialog for some reason. Do you have this little playhead down here at the bottom?
Yes, I have that, but I just don't have the control of this dialog box.
Okay. And yeah, if you don't see it minimized, maybe check if you have multiple monitors. Maybe if you've gone in there before, that toolbar, that panel could
Okay,
have been left on another monitor.
I see. Yeah, it's dual monitor.
Okay.
It's behind this.
Ah, very good.
Okay, gotcha. Thank
All,
you.
all right. Great. No trouble. Now, we don't have a whole lot of time left, but I'd like to at least do the next setup. So what we're going to be doing is preparing to do the second set of operations. Again, I can share step-by-steps with Francis. This is also, I don't know if this is a built-in tutorial, but there are a lot of built-in tutorials around CAM and Fusion 360. Under the help menu in the upper right, the little question mark, you can go to self-paced learning. There's lots of different menus. Also on the Autodesk certification site, we can do this. So to create our second setup, I'm just going to hit escape to get out of my simulation. What we want to be able to do is to be able to get to our second operation, and we're going to relocate. Now, this one I particularly want to show you because this isn't a workflow that's used all that commonly, but it can be very powerful. And ultimately, I want my part to be in the fixture with an orientation something like this. So I'm going to rough this in to help myself out a little bit. I'm going to expand the Models tab and expand my bracket. And down here under Sketches, I'm going to turn on a G55 sketch. Okay. This is the ability to base a coordinate system on a sketch point. In this case, we'll be able to, when we flip this part over in the fixture, we'll be able to probe the flat faces and figure out where that bottom corner is as that part sits down flat in our vise or our fixture. So that's where this is fairly valuable. To do this, I'm going to create a new setup. Again, by expanding models, expanding the cam or the part, expanding sketch and turning on the G55 sketch, I can change my orientation, my origin to be based on a selected point. So I can pick that point, flip my Z over. It's not quite giving me the right X direction, so I'm going to pick on the shaft of X. Now this will probably skew this again, so I'll have to reselect it. It didn't in this case. So I need to flip it. So I want it so my X is kind of pointing off to the right. My Y is going back away from this back corner, and my Z is going up. Okay. The next thing that I want to do is make sure that instead of using a fixed size box or a relative size box, that I'm working from the preceding setup. So it's going to be aware of the fact that we might have started out with a big block of aluminum or steel, but now we've got some features already made and we need to take those into account. For example, the fact that these finished faces are here on the sides and around the perimeter. So we'll use from preceding solid and we'll have it really take that into account by saying continue rest machining. So it knows it's going to take on the fact that other materials already been removed. we can give ourselves a new program number and give ourselves a new coordinate offset, right? And I'll just click OK. And you'll see now it recognizes that block as the material. It's also narrowed the box down to that footprint. So let's have you go ahead and do that.
Regarding the file management system, not regarding this.
Oh, I see.
Sorry?
So sorry. One of our members here has a question for you. What was it again?
Okay.
It's regarding the file management system and not regarding the current topic. So I can ask it later at a later point in time.
What about the file management system?
Oh, so he had a question concerning the file management system. So he will ask you again at a later time. Sorry for the.
Okay.
Yeah.
I'll be sure to share my email at the end. Please feel free to send me an email with the question and we'll work through it.
Thank you, sir. And there should be more questions.
Okay. Are we ready to go on?
Yes, sir. On our side,
Okay.
yes.
Great. All right. So we're not going to do everything for this part, but remember that we do have a chunk of metal still sitting here. This is what was in our vise during our first operation. So the first thing we're going to do is essentially go through it and create a facing operation. And I need to select a new tool. And I'm going to select tool 7 and do aluminum roughing. I just double clicked on that. It gave me that. For my heights tab, I want to make sure that it's working from the stock top for the top height. And the bottom height is the model top. This should generally be the default for any facing operation because it's removing whatever stock is left over to get down to the top of the model. Now, one other option on the passes tab I can use is to engage multiple depth step down. So I can have it step down through the material rather than kind of hogging out the material. So we'll put that on and just leave it at whatever the default is. And you'll notice that it's going to cut this out. I can just quickly simulate that. And you'll see what this operation looks like as it just works its way down to the material, down to the finished face of what will be the part. All right, let's have you go ahead and do that operation, and then we'll take a look at some other concepts. And I want to point out a website that I've mentioned before, but I want to show you a couple things.
Good to go, sir.
All right, great. So what I want to do is I'm just going to walk through the PowerPoint just to show you the additional operations that the tutorial has. And again, if you'd like the tutorial, I'll show you my email here in a few moments. Feel free to write me, and I'd be happy to send it just as a PDF. It basically talks through how to cut out these pockets, how to add the chamfer around the outside edge. Now that chamfer does exist in the CAD file, and it's a really interesting process how to do a chamfer. The key is to use the lower edge to be able to select that. Then just using a quick drill operation to again soften the edges of those holes. And one more time adding a couple additional chamfers just to make that part a little higher quality part. Then a little later on, we'll create a third operation where it will create a bore, chamfer the top edge of the hole, and then use a underside chamfer tool to cut the backside. Then the fourth operation is actually the same program by flipping the part over in the fixture. So that's another area where you can economize value. So let me skip through that. Then one last thing, let's do this. When you're done with your tool paths, the last stage is to generate your, to export to post-process your code. Now, one of the things I want to show you is that if I come into this, I can use the machine configuration if I had selected what type of machine we were going to be on. Otherwise, I can choose a post from the library. So just to give you an indication, the Fusion 360 library has post processors for all of these types of for all of these manufacturers. And in many cases, especially when you get into FANUC or you get down to Haas, they've had a lot of different standard controllers and processors over the years. So you can find the type that works best for your machine. If you're not sure, talk to either an expert in the shop or consult the manufacturer. They'll be able to recommend it. There's an enormous numbers of post processors available built into Fusion 360. When you select the processor you want, you can choose where you want the path to go. I'll just pick someplace. It's copying it. I can tell it whether or not to do any of these options for that particular processor, and your options and preferences will be different for the type of system you want. And you can even tell it to open in the NC editor to be able to view the G code when you're done. And let me just bring that onto the screen here. Oops. I grabbed the wrong thing. Oh, what I did was I chose poorly on my machine. I should have been more careful, but essentially it's a series of G codes. That's where you frequently hear the phrase G code, and the coordinates and the option information. One of the things I wanted to point out with just these last minutes, actually we're at time, is on the autodesk.com/certification page, you can go and pick types of certification. You can go in and look at the different types of certification. There is a certification for CNC, CNC with Fusion 360. So let me get down to design and manufacturing. Here's a 2.5 axis. The certification details. And the other thing is you can find a learning path specifically for this certification. Now, one thing about these higher level certifications is they require some time actually using the tool, so you have a feel for the nomenclature for, what is the name of the thing that actually holds the tool, that is either drawn into place or screwed into place. That sort of information is part of it. But here are some various courses that will take you through some additional learning focused directly on the type of equipment that you're going to be using. Blueprint basics, CAD basics. So you see this certification is above just the software. And what's important, and the reason I bring this up, is in a competitive marketplace, certifications like this are incredibly valuable. They're also, the reason they're incredibly valuable is they show that you're going to have a different level of insight into the design process because you have a deeper insight into what the manufacturing process is. I mentioned this before as something that's valuable. It really is incredibly valuable to have that knowledge. It gives you a great leg up, especially if you're starting a new career or just coming into the workforce. Just some fantastic information that's already available. The certification, there is a charge for the certification. I can't say for certain, but I thought University of Houston was a certification center for Autodesk, but definitely want to check that. But this prep course is free and gives you a great learning opportunity to not just get more in depth with the CAM tools, but to understand their application. And there are a lot of other certifications similar to this. Go check it out, autodesk.com/certification. Just do some exploration there. Again, there's still all these tools. This is a certification course. And one last time, please feel free to drop me a note. If you'd like the handout or the PDF of the various steps out of the PowerPoint, just drop me an email, let me know. I'll be happy to send it to you. It's a fairly small file. I think it's a couple megabytes, so it's not a big file. So I'd be happy to send it to anybody. Otherwise, I do appreciate your time and thank you once again for the opportunity. I wish you all the best and enjoy using Fusion 360. And I'll stick around for a little bit if there's some additional questions. But if not, thank you again for your time.
Yes, Tom, we do have one question.
Great.
So I have bought a Fusion 360 subscription. And what if I discontinue my subscription for a couple of years and then resubscribe? Will my data in the cloud still be available for my use after 2 years? And if so, for how long does Autodesk holds my data?
I don't know off the top of my head. I know I have data. Well, I haven't had a break in my access though. I would have to look into how long if you cease your subscription. However, with that said, one thing I would recommend doing if you have data that you know you might want to come back to, but you know for a fact that the Autodesk ID that you're going to be using is going to not be used for a while, that data is associated to, is you can always take a file and export as an F3D archive. Okay, either right out to a location on your computer. That F3D will maintain the design history. If it's an assembly or a file that has a drawing associated to it, or a file that has multiple components linked to it. Let me find an example here. Actually, let me just pop over to here real quick. Grab this data. Whoops, actually, I didn't need to do all that. The proper way to back that file up or to have a copy of it is to go to the web details or just log into your Fusion team. And what you can do is select that file and export it as it will be an F3Z file, because there's in fact, this is kind of the ultimate example. There's an external file that's used and there's a drawing associated with it. Okay, so for this, let me go back up a level here. You would come to that file and you would go to download Fusion 360 archive. This will essentially create an F3Z file, which is a very advanced version or a specialized version of a zip file that will contain all of the relationships between those files, all of their history, and it will capture the drawing and its associativity. Later on down the road, you can then go back into Fusion 360, and through the upload tool, you can pick that Fusion archive file, tell it where you want to put it on your new tenant, and it will expand out all that detail in the project or in the folder that you pick. I might do that just for safety, but if you could do me a favor and drop me an email and ask me that question again, and I'll send it off to a couple people I know and see if we can get a concrete answer on the how long it would be. If you could put in any information about why you would be moving away from your subscription to come back, if it's the fact that you've got a paid subscription now, but you just want to use your student account for a while and then come back to it, that's a great reason. But if you could put that information in there, but I'll get you an answer on how long that data is just allowed to stay up on the cloud.
Good. What were you saying, sorry?
That was very helpful. Thank you so much. I'll make a point to drop you an email about this.
Yeah, please do.
Thank you.
You're very welcome.
Any more questions before again? Awesome. Thank you again, Tom. Thank you so much for the time you have given us. We very much appreciate it. And we hope to hear from you again soon as well for future events as well with Autodesk and learn
That'd
more
be
about
great.
Fusion 360.
That'd be great. And if I'm able to send out an evaluation, please do follow through on the evaluation. The number of evaluations we're able to submit to Autodesk makes it possible to do events like this. And of course, hopefully the performance is good.
Yes, sir. Thank you, sir. And I will be going ahead and updating the Excel file with all the names and emails of the attendees for the past 3 events. And I will be sending it to you as soon as I can.
Thank you. I appreciate it.
Thank you so much as well, sir.
All right. Have a great night, everyone. Take care.
Thank you.